Good day, fellow scientists, and we are back again at tackling maths and science with your favorite sensei, me, Sensei Mohau. And if you are new to our family, welcome to the family, welcome to the club, and please press the subscribe button down there below, and also that notification bell, so that you'll be notified and get post notifications whenever we post the new lessons. And if you have any inquiries, if you want me to be a personal tutor, you can name it. Either geography, math and science. I have a team that is ready to help you in all your academic problems. So just hit me up at 081 537 9527. It's 081 537 9527, or you can just email me at mohau09@gmail.com. It's there in the bio. So today we'll be tackling analytic geometry question. It's on June 2022 past paper. So let's begin. It says, question 4, in the diagram below, the coordinates of A, -4 and 5, which is this, and C, -1 and 4 is this, and B, 4 is to 1, are the vertex of a triangle on a Cartesian plane. CE is perpendicular to AB with E on A. So E is the midpoint of straight line CD. It's this one. AB. Remember the gradient of AB, it's this one. So definitely it must give us a negative gradient because the slope is decreasing. So it's M. Let me change the color. It's M AB YB minus YA over XB minus XA. So now it is for the B1 it's 1 over 4 for this one, and for this one it's 5 minus 5 into negative 4. So it's -4 over 8. Our answer will be -1 over 2. That will be our answer for A. So number 2 says, determine the gradient of line CD. So now remember that for us to find the gradient of the equation or of the line, we can use this equation or this one, but all of them, please note that all of them, they require us to find the gradient, but here we do not have the coordinates of this. But remember that they told us that CE is parallel. Sorry, why do I keep on saying parallel? It's perpendicular to AB. Yeah, parallel, it's in my tongue, I just don't know how. So now we know that since that AB is perpendicular to CD, because of it, if it is perpendicular to the CD, it is also perpendicular to the whole thing. So we know that the gradient will be the opposite of it. So it's minus CD and -1, and now it's -half multiplied by MCD. So we divide both sides by this one, similar to doing this. multiply with the reciprocal. We multiply also here with the reciprocal. It will be mxcd is positive 2, which is the gradient of this line CD. So now we have found the gradient. We can use this one. So we're gonna say y equals to mx plus c, and it's negative 4 equals to m, which is 2x minus 1 plus c. For us to solve for c, it's this side will give us negative 2 plus c. We take this to the other side, it will become a positive 2 equals to c. Then our answer will be negative 2 of c. So the equation will be like this now. Y equals to m, no, it's 2. Let's just substitute 2x minus 2. So this will be the equation of line CD, or we can just use this one. Here we do not have to find the constant term, but it's a matter of whether they told you that you can use this or that one. You can just use basically any equation unless they told you to use the particular one. So it's y minus 4. Remember that y1 and x1 are the coordinates. So it's minus into minus 4, which is just y plus 4 equals to 2x minus into minus 1. So it's 2x plus 1. It's y plus 4. So this will go to the other side. But first, let's do both mass here. It's 2x plus 2. Then here, this one will go to the other side. It will become a negative 4. The answer will be 2x minus 2. It's the same thing. So now, let me just remove this ones here so that we can have space. So it says find the coordinate of E. So you can see that E is the midpoint here, and E is also the point of intersection for both line AB and line CD. So now we can use both the midpoint theorem, but remember the midpoint theorem requires us to know the coordinates of D, and we do not know them, unfortunately. So now we just use the point of intersection rule, whereby it is just the y, or it's the equation of AB. We equate it to the equation of CD, and previously we found that the equation of line CD is it's 2x, and it was y equals to 2x minus 2. So we just substitute this because they represent the y, and we have to find the equation of this AB. We know the gradient is minus 1 over 2. So let's try to find the constant. We finding the equation of this. It's y equals to mx plus c. Then we substitute. Which one should we choose? A, B, A, B. I'm just gonna go with B. So it's 1 negative half 4 plus c. So this will cancel each other out. We will be left with 2 here. So it will be minus 1 multiplied by 2 plus c. Then 1 here on the other side. So it's minus 2. It's 1 plus c. So this will go to the other side. It will become a positive 3. Oh, sorry. Positive 3 meaning that it will become a positive 2. Then 1 plus 2 will give us 3. So now the equation of this, now it is y equals to half x plus c, negative half. So now this is the equation of this line AB. So it's minus half x plus 3. Let's erase this one now here. So now we have to solve for x. Sorry, we have to solve for x, so we take this to the other side, the numbers to the other side. So it's 3 plus 2x minus 2x. This will become positive. It's plus 1 over 2x. So it will be 5 equals to, it's gonna be 2 over 4 plus 1x. It's gonna give us 5 over 2x. 5 over 2x equals to 5. Then we have to divide both sides by this, or multiply by the reciprocal on both sides. It's multiplied by 2 over 5 multiplied by 2 over 5, and this will cancel each other out. So our answer will be left with x equals to 2. So which is the equation of E, the coordinate of E. So now we have to find the y coordinate. We can just substitute in any equation, either this one of AB or this one of CD. It will give us the same answer because it is the point of intersection between these two equations or these two lines. So I'll just use this one of CD. 2 into 2 minus 2, it's 4 minus 2, it's 2. So y coordinate is 2. So E, the coordinates of E are 2 and 2. Okay, so now let's move on to the next question. Find the coordinates of D. Now we can just use the midpoint rule, that since you know that E is the one in the midpoint, and this one and this one are the one on the outer parts, it will be x of E equals to x of D plus x of C over 2, and y of D plus y of C over 2, and this is for the y coordinate, and it will be two equals to -1 plus, -1 plus x, let's just say x over 2. We multiply both sides by this so that it can cancel out the denominator. It's multiplied by 2, it is 4 minus 1 plus x. It's then, now we solve for x algebra, we take this to the other side, it will become a positive 5 when we add to 4. So now here on the side it's gonna be 2 equals to 2 over -4 plus 1. So the same rule, we cross multiply or multiply with this denominator on both sides. It will be 2 times 2, which is 4. Then now we are left with -4 plus y. Then here it will be this to the other side, it will be y equals to 4 plus 4 will give us 8. So coordinates of D are 5 is to 8. So now this question says determine the equation of the straight line passing through D and parallel to AC. So which means that the straight line passes through, let me change the color. So it is parallel to AC, which means it's like this. Yeah. So it's like this and it passes through D. So now we know that the lines are parallel. I'm gonna say AC is parallel to the line, let me say D. Yeah, that passes through D. Because they are parallel, the gradient is the same. So gradient, equals to, let me just erase that. they are equal, and because of the lines are parallel. So now let's find the gradient of this. So now it's MAC, it's 5 minus 4 minus negative 4 over negative 1. So here we will get 9 over negative 4 plus 1, it's negative 3. The answer will give us negative 3, which is our gradient. So now it will take the same gradient, and we found that this coordinates are 5 and 8. So the equation will be like this: y equals to mx plus c. We found the gradient because of the lines are parallel, x plus c. Now let's substitute this to find the constant term. It's 8 here. It's minus 3 times 5 plus 3 plus c is negative 15. It's 8 plus c. So this one goes to the other side. The answer will become a negative answer. C is equal, so the answer will become a positive answer, 23. So the equation is y equals to minus 3x plus 23. We can prove it. It's in the calculator. If we do this, the answer must give us an 8. So it's minus 15 plus 23, which is just 8. Take sign of a bigger number and subtract, you will get 8. So this is how you do this question, by showing all calculations whether x-intercept of straight line CD lies along, also lies on the altitude perpendicular height from A to BC. So now, first of all, what do we know about the perpendicular height or the altitude? Yeah, altitude is a perpendicular height. So now, if this, then it's a perpendicular height from A to BC. It's gonna go like this, from A to BC. It's gonna go like this, since they say that does it touch whether x-intercept lies on the altitude. So which means, let me just do it like this. So now, which means we know the altitude is 90 degrees, and because it's perpendicular. So now we're gonna check whether the x-intercept of this altitude, we're gonna find the equation of the altitude and check whether the x-intercept of this altitude, it is equals to the x-intercept that is on the line CD. Okay, so let's do it like that. So now, first of all, we must find the equation of line CD. So now, we know the gradient. Because of it is perpendicular to BC, the gradient will be the opposite and negative of that answer. So let's find the gradient of MBC. The gradient of MBC is 1, 4, minus negative 4 and negative 1. And it will be 5 because of it will be positive and positive here. 5 over 5 is 1. So now the gradient of the altitude, because these lines are perpendicular, let me say altitude, it will be equal to negative 1, so it's the opposite of it. So 1 divided by negative 1, it's minus 1. So now here we have found the gradient. The gradient is negative 1. So now we know that the points on this altitude is this one, A. So it's minus 4 and 5. Then let's find the constant So now the altitude, the constant will be c is 5. This, when we multiply it, it will give us a positive 4. So positive 4 going to the other side will be negative, and the answer will be, so the constant is positive 1. So from here, the new equation of this altitude is y equals to negative x plus 1. It's the new equation. So the x-intercept of this, x-intercept, we know that y is 0. So where there's y, you substitute 0. So it's 0 equals to negative x plus 1. This goes to the other side. It will become positive 1x, which is the x-intercept. So now let's find the x-intercept of this line CD. So line CD, we already found the thing. We already found the equation, I think, in the previous question. The equation is 2x minus 2. So here the x-intercept of line CD, we know y is 0, and it's 2x minus 2. Take this to the other side, it will become positive, and divide by 2, divide by 2. So x will be 1. So you can see both x-intercepts of these two lines, CD and the altitude, are the same, which means they are like the same point, which means that they lie on the, they intercept in a way, because of it is the same point right here. And thanks again for tuning in. If you have not subscribed to our channel, please do the right thing